Hello, let's look at part D. So, let's go ahead and scroll up and look at part D. So it says if the incline is frictionless, so once again, we now have a hoop. Instead of a box as we had for part A and B, we now have a hoop that's rolling up or moving up. It says if the incline is frictionless, determine the maximum height to which the hoop will rise in terms of h. Okay, and the given quantities. So, for this one, we're once again trying to find our height, okay? Let me go ahead and change that. So we're really trying to find our height, how high we go up, and we want it in terms of capital H, which we found in part A, right? So we found that our height was v squared over 2g, okay? Now, if there is no friction, right, so mu equals 0, that means there's no friction. That means however much it's rolling isn't going to change, right? That's not going to change. Now, the question is, how do we approach this problem? Well, we're going to approach it very similar as we have kind of A, B, C, and D. We're going to use energy. Okay, so we just have EI equals EF. Okay, and then our initial energy, we're going to have KE, and since it is rotating, we will also have KE rot. Okay, so it does say that it is moving up the incline plane, right? And originally we saw that it is rolling. Okay, now it is going to be moving up. So I have KE plus KE rot, and that's going to equal PE plus still KE rot. The reason I have a KE rot at the beginning side and at the end side is because since there's no friction, that value, that amount won't actually change, right? There is no external torque. If there's no external torque, then the angular velocity can't change. If the angular velocity can't change, our KE rot isn't changing, which means that I have the same value on both sides of the equation. So this is just going to cancel out, right? I'm going to subtract KE rot from both sides of the equation, subtract KE rot, and so now I'm left with just KE equals PE. Okay, and this should look really familiar because that is identical to part A. Okay, so I just need to plug in. So plug in again, 1/2 mv squared equals mgh. M's cancel. Okay, I'm solving for h. So I will have 1/2, or let me rewrite that. So I'll have v squared divided by 2g equals h. Okay, and so that will be my final answer, or not my final answer quite yet. But that will be my h. That will be the height it goes. And we know that this is just equal to what we got for A, which is capital H. So my final answer here would be the height that it's going to go up to is the same as h. Okay? So h, capital H, is v naught squared over 2g. The answer we got for this was v naught squared over 2g. Okay? And so it will go the exact same height, because the angular stuff will have no effect if the angular velocity is not changing. Okay, and so that was 1990 M2. Thanks so much.